These are the last set of problems from section 5.7 I want to go over with you. So 37, 39, and 41. So 37, if you look at this problem, you may think that you need to go through completing the square in the denominator so we can match up with the rule that's available to us. However, if you look at this, this is simply going to be a u substitution problem. If we let the u value be negative x squared minus 4x, our derivative will be in the form where it will cancel out nicely with the numerator. So this is actually just a simple, or actually just a u substitution problem that is mixed in to this section. Okay. Our u value is just going to be what's inside the square root, so negative x squared minus 4x. Our derivative is negative 2x minus 4. Solve for dx, we get negative 2x minus 4. This doesn't quite match up perfectly with the x plus 2, but if we just factor out a negative 2, then we have x plus 2, and that will allow us to cancel out. So solve for dx, which is du over negative 2, parentheses x plus 2. Replace the x plus 2 will stay first, stay initially. We have the u inside the square root. Dx gets replaced with du over negative 2, parentheses x plus 2. The x plus 2 cancels out. We have to keep track of this coefficient, pull the negative 1/2 out, times 1 over square root of u du. This is not a natural log rule. Natural log is only u to the first power in the denominator. Any other situation, we have to go through power rule. But to do power rule, we can't have the variable sitting in the denominator. We have to bring this up. So if we bring this up to the top, it becomes square root of u, and we also, becomes u to the negative 1/2. We also need to make sure that we have the rational exponent with the appropriate negative 1/2 in front. Okay. All right. So now we can apply the power rule. U to the negative 1/2 becomes u to the 1/2 over 1/2. We still have that coefficient that we keep track of. The 1/2 can be flipped to be just 2 over 1, and the 2's cancel out. We're left with negative u to the 1/2 plus c, and replace our u value back in terms of x. So negative square root of negative x squared minus 4x plus c. All right, 39. If we let the u value be what's inside the square root, we get 4x minus x squared. Our derivative is 4 minus 2x, which is negative 2x plus 4. And however, we see that 39 looks a lot like 37, but our u substitution is just not going to cancel out perfectly with the numerator of our original problem. So this goes back to where we have to split up our equation. We want to write it as two fractions. In the first fraction, we're going to write it so that we can use u substitution to cancel out, but then we need the second term to make up for the fact that it's not the same as the original numerator. So 2x minus 3 is equal to, we want the 2x minus 4, we want that to cancel out. But if we have 2x minus 4, we also would need a plus 1, because 2x minus 4 plus 1 is equal to 2x minus 3. We need to maintain balance from our original problem. Okay, so this is u substitution. We know that's going to work because we have a negative parentheses 2x minus 4. dx gets replaced with du over negative parentheses 2x minus 4. The 2x minus 4 cancels out. The negative 1 comes in front. Square root of u, this is a power rule. Make this u to the 1/2. Bring it up to the top. Make it u to the negative 1/2. We go through power rule, so negative u to the 1/2 over 1/2, which is negative 2 u to the 1/2. And then our u value gets replaced back in terms of x. Now the second section here, this is square root of 4x minus x squared. This we actually are going to have to use. It's actually going to match one of our Trig rules, and it's actually going to be an Sine Rule. Okay, you may not be able to see this initially, but first step we need to do is we need to get this to look like one of the rules. So we're going to have to go through completing the square. So if we complete the square, we want the x squared first, followed by x to the first power, However, we have a negative x squared, so we want the x squared to be positive, so we pull the negative outside, parentheses, we change the signs of what's inside here, and we add the spaces. B over 2, our b value is 4, so 4 over 2 is 2. 2 squared is 4, so 4 goes in both spaces. Now, this looks like a positive 4, and it is a positive 4 inside the parentheses, but if you distribute this negative through, then this is really a negative 4. So if I have a negative 4 here, then I would need a positive 4 to cancel out. Okay, factor, this becomes x minus 2 quantity squared. This 4 becomes 2 squared. So I want to rearrange with the positive term in front. So square root of 2 squared minus x minus 2 squared. Now this will match up nicely with the Arctangent Rule because Arctangent Rule has the constant first. A value is 2, our u value is x minus 2. So now we have, we can simply plug in du over square root of a squared minus u squared is arcsine of x minus 2 over 2. This is a definite integral problem. Normally I would convert the bounds to be in terms of u. However, these are two separate problems, and then the u values are different for each. So just to make things a little bit easier, make more straightforward, I'll just rewrite everything in terms of x and then plug in the original bounds, right? As long as our value, our antiderivative is in terms of x, we can just plug in the upper and lower bounds as we see it. So upper bound first, 3 goes in for x. So this reduces to be square root of 3. 3 goes in for x, so this is arcsine of 1/2. Arcsine is equal to 1/2 at pi over 6, so that's my second term there. Minus, now plug in the lower bound, 2 in for x, and this reduces to be 8 minus 4, which is 4, so square root of 4 is 2. 2 times negative 2 is negative 4. And then minus, now, plus, this plus here, arcsine of, now we plug in the lower bound here as well. So 2 minus 2 is 0, 0 over 2 is 0. When is sine equal to 0? Sine is equal to 0 at 0. So all these terms we can write it as separate since we can't combine it without using a calculator. But if we combine using a calculator, we can get a decimal value of 1.059. All right, last problem. Number 41, if you look at the denominator, we can try and go through completing the square, see if we can get this to look like one of, most likely the arctangent, because we don't see the square root. We have put the spaces in place. Our b value is 2, so 2 over 2 is 1, 1 squared is 1, so we put a 1 there. And when we factor this, this is x squared plus 1 quantity squared, and 2 minus 1 becomes 1. So we have everything that is set for us with our u value being inside the parentheses that involves the x, and the a value being the constant. So our u value is x squared plus 1, our a value is 1, derivative is 2x, dx equals du over 2x. We make our substitution. Numerator stays as x. Denominator is u squared plus a squared. Dx gets replaced with du over 2x. The x's cancel out. Make sure we keep track of this 2. The 2 comes out in front as 1/2. So now we have something that matches nicely with the arctangent rule. So arctangent rule goes like this. 1/2 is the coefficient, and the rule says 1 over a times arctangent of u over a plus c. Our a value is 1. Our u value is x squared plus 1. So we can combine this to be simply 1/2 arctangent of x squared plus 1 plus c.